Hey everyone, I wanted to give you another introduction to a little bit more graphing, and this time we have a new little twist and maybe a little trick that some of you may know, and many of you probably do know, but many of you may not know because you haven't necessarily graphed a lot of data. And then probably at the end I will probably try to maybe show an additional step of what one could do, but it won't be required for the results section that I want you to write. The first thing I want to do is I want to generate my x-axis. My x-axis, if you remember, you collected 1 milliliter fractions, and you collected, generally most of you collected 24 fractions. The total volume was a little over 20, was right around 24 milliliters. So what I'll do here is just go ahead and copy these numbers. I'll paste them in over here. And what I'll do is I'll just highlight a few of these numbers and just go on down. And if you notice right here on the column, you see that right now the last number in that series will be 24. You don't know if you see that in there. So now I have that. Now I'm going to go ahead and generate, just to give me some points so that I understand where I'm going. I go ahead and do 620 nanometer and 440 nanometers. So we gathered data. This is the 620 data, and this is the 440 data. So what I'll do here is I want to get this data over to here, and I want it to be in one nice little column to make it easier to graph. So I'm going to hit equal here, click there, hit enter, and then I'll highlight that and then copy this down here. Next, now this is fraction 13, so I'll go ahead and put an equal sign here, there, equal, and then I will copy that down as well. Now I'll go ahead and put the 440 data in it. I'll do it exactly the same, use the same exact approach. Copy that down into here. And then for 13, it'll be in that next column. So it'll be right here, hit enter, and then highlight that again and drag it down. So what I've done here now is I've created 2 columns of data. It's all continuous. So I now have the x-axis data, which is the volume of elution, which is 1 to 24. I have all the absorbances for each milliliter fraction. We'll just go ahead and assume that's fraction. And then I have all the 440 data. So what I'll do here is I'll start my first part of the graph. And it's always easier to go ahead and just to do just your first 2 parts of your XY scatter plot. So I'll highlight all the 620 data, and I'll go up here to insert XY scatter, and I'll choose this one. I like that one. This one, yeah, it could be okay, but I like the look of this one a little bit better. So I now have a graph. You see that, as you remember, the blue dextran came out early. The blue came out, and you said it was the excluded volume, the void volume. This excluded volume. And next I'll go ahead and select data, and I'll add the other set of data in here. I'll click add. The series name will be 440 nanometers. X-axis will be this value here. And notice that I only highlighted the numbers. Same here. I'll do the same thing here. Hit enter. Okay, so here we go. So here we have the basic graph. So we have, if you remember, the ferrocyanide, the yellow colored eluted from the column, was much, much brighter colored, and kind of, for a lot of people notice, kind of looked like Mountain Dew coming off of the column. And here we have the blue dextran, which was pretty low concentration, so the absorbance was not particularly high. But we'll go ahead here and we'll go ahead and finish this graph, and I will show you the minimum of what I want to see in your results section that you turn in to me. So here we'll go to Add Chart Element, Axis Titles, Primary Horizontal, and we'll go ahead and put volume, or maybe elution volume, and I always like to put units in the axis. So we have the elution volume in milliliters. And now we have two absorbances, so let's go ahead and the vertical axis here, we'll go ahead and name that absorbance. And then, I like, since there's two, who knows the difference between the blue line and the red line? A lot of times I like to just go ahead and put a legend to the right, and you'll see that the blue is 620 and 440. And if I wanted to be clever, I might turn that to yellow, but yellow doesn't show up particularly well against white. Another thing that I would probably do here is I would just double click on this horizontal values here, and I think that puts a lot of white space here that I don't particularly like, so I'll just go ahead and change that number to 25. Makes the graph look a little bit nicer. Maybe I'll go ahead and add another chart element, the chart title above the chart. Gel filtration of blue dextran and potassium ferrocyanide. Oops. So here, this is sort of the minimum I would expect in a graph for your assignment. And you have here, you can comment about in your results section. I want you to talk about. You saw two peaks. Maybe you can say one was a much smaller peak, one was a much larger peak. You might want to make comments. Here looks like the blue dextran came out in 3 fractions, while potassium ferrocyanide came out in probably looks like maybe 9 fractions. Or you might be able to rationalize what happened, why that's happened. It could be due to concentration, but it could be maybe due to another factor. And these peaks, you kind of look at these peaks, this peak here and this peak here. If you remember back to your statistics class that you that you probably have taken, these data should be normally distributed. And there's a reason why, and I want you to think about that, and maybe you can put that in your results section. Okay, what I'm going to do here is, this is purely optional, and this is kind of more of an advanced feature in Excel. But a lot of times when you're presenting data and there's such a large difference between them, it's nice to have two y-axes, and that way you can normalize the data and have them sort of all the same heights. So what I'm going to do is click Change Chart Type. We're going to go down to Combo, and we'll do here, we'll go down to here and have XY scatter, make this XY scatter, and that kind of looks kind of nice here. And which one do we have as a secondary axis? I think let's have the 440 as a secondary axis. So now we can click OK, and now it readjusted our axis. So let's go ahead and change this back to 25. So now we have the blue dextran here. You can more clearly see it's about maybe 4 fractions wide. Wow, this is about 8 or 9 fractions wide. This kind of looks a little bit nicer. And now we have axes, the y-axes, that are not necessarily labeled correctly. So let's go ahead and just double click on this one, and we'll go ahead and click inside here. So this is 620 data, so just click there, so it's absorbed to 620. Now we'll add a chart element, axis titles, and now you notice that once you have a secondary axis here, it'll give you a possibility of a secondary vertical axis. So let's go ahead and click that, and we'll type in absorbance 440 nanometers. So now you have a graph where the two items have been scaled, and this is by far the easiest way to scale these two. If you get into Excel a bit more, there's some more things you can do to calculate. You can use math and things like that to scale your peaks, but this looks a little bit nicer, a little bit more information, and it might be a little bit easier for you to interpret. So guys, if you guys have any questions, I want you to think about observations you made during the experiment. And one of the recommendations I have for you is to go ahead and write down things as you see them. For example, you can write down that the yellow and the blue band separated relatively rapidly, and it looked like the blue band moved down the column faster. It's a second observation. Maybe I think some people noticed and commented to me that they noticed that the blue band moving down the column never seemed to get as broad as the yellow band. There might be reasons for that. Might be due to there might be a normal distribution involved there. So you can think about sort of distributions and what might cause that normally distributed data to cause there. So think about different things. I think there's 3 or 4 or 5 observations you can make. You can make sort of comments and observations. You can always link them to things that you know happen. So you can say that the two compounds should separate from each other because of the large molecular weight difference of blue dextrin being over 1 million, potassium ferrocyanide I think is about 600. So those are pretty different molecular weights. So you'd imagine they would separate by a great distance. So I want you to think about those kinds of things in your report. And put this in, I want you to have just a couple of observations. Since we weren't able to have cytochrome C this semester, we're not going to write anything up about, we're not going to try to generate a standard curve or anything like that. So hopefully this helped, and if you have any questions, send me an email. I'll see you later.